Model pruning in distributed systems with AWS and SageMaker. Definition: model pruning involves reducing the size and complexity of machine learning models by removing unnecessary parameters and connections, optimizing performance, and reducing computational resources in distributed systems for large language models (LLM) and retrieval augmented generation RAG projects. Leveraging AWS, Amazon Web Services and SageMaker. Key components: AWS services, SageMaker, fully managed service for building, training, and deploying machine learning models at scale. Integrated with AWS services for model pruning in distributed computing. EC2 instances. Elastic Compute Cloud instances for provisioning virtual servers with varying compute capacities and optimized hardware configurations. AWS Lambda, serverless computing service for executing code in response to events, optimizing resource usage and scaling model inference in distributed deployments. AWS Elastic Beanstalk, service for deploying and managing applications in the cloud, automating resource provisioning and scaling for distributed computing environments. AWS Nitro System, hardware and software infrastructure that accelerates and optimizes storage, compute, and networking tasks, improving overall system performance. Model pruning techniques. Weight pruning removes redundant or low-impact model parameters weights based on magnitude or importance scores, reducing model size and computational requirements. Neuron pruning eliminates unnecessary neurons or connections in neural networks, optimizing network structure and improving efficiency in distributed computing setups. Structured pruning targets entire layers or sub-networks for removal based on connectivity patterns or functional redundancy, streamlining model architecture in distributed environments. Iterative prune retrain applies iterative pruning and retraining cycles to maintain model performance while reducing size and complexity, optimizing resource utilization over time. Benefits: improved performance, enhances model inference speed and efficiency by reducing computational overhead and optimizing resource utilization through model pruning in distributed systems. Reduced resource usage, lowers memory footprint and storage requirements by minimizing model size and complexity. Optimizing cost efficiency in compute-intensive applications. Scalability and flexibility. Improves scalability and flexibility in distributed environments by deploying smaller and more efficient models. Supporting diverse workload demands. Faster inference speeds. Accelerates model inference speeds and response times by optimizing model architecture and reducing computational redundancy through pruning techniques. Cost effectiveness. Optimizes operational costs and resource allocation by deploying pruned models that require fewer computational resources and storage in distributed setups. Tools and technologies. AWS SageMaker, fully managed service with built-in algorithms and frameworks for implementing model pruning techniques and optimizing model performance in distributed computing. AWS EC2 instances. Elastic Compute Cloud instances for provisioning virtual servers with optimized hardware configurations and scalable compute capacity in distributed deployments. AWS Lambda, serverless computing service for executing code in response to events, automating model inference tasks and optimizing resource usage in distributed environments. AWS Elastic Beanstalk, service for deploying and managing applications in the cloud, automating resource provisioning and scaling for distributed computing setups. AWS CloudWatch, monitoring and management service for tracking model performance metrics, optimizing resource utilization. and scaling model inference in distributed systems. Challenges: performance size trade-offs. Balancing model size reduction with maintaining adequate performance and accuracy levels when implementing pruning techniques in distributed setups. Compatibility and integration. Ensuring compatibility and seamless integration of pruned models with existing software, frameworks, and infrastructure in distributed computing environments. Iterative optimization. Iteratively optimizing pruning strategies and retraining cycles to achieve optimal model performance and resource utilization in distributed deployments. Data integrity and accuracy. Addressing potential issues related to model accuracy and data integrity when applying pruning techniques to complex machine learning models in distributed systems. Training and skills. Building expertise and skills in implementing and fine-tuning model pruning techniques to maximize performance gains and efficiency in distributed computing environments.